Myself, I am Dr. Jntuh. In this class, I am going to discuss with the various scheduling algorithm. Before moving to the topic, so which we are all the scheduling algorithm we are going to discuss now is SJF, shortest job first scheduling algorithm, priority scheduling, and round robin scheduling algorithm. Out of which, shortest job first scheduling algorithm is the most important CPU scheduling algorithm. Depending upon the length of a progress, it is going to be divide the burst cycle in the forms of millisecond. So this is an example sequence of the shortest job first scheduling algorithm. Here the process ID and the burst time are listed. For the processor P1, it having a burst time of 6, process P2 is having 8, P3 is having 7, and P4 is having 3. So this can be represented with the help of a Gantt chart here. So here we have to take the process which is least number of values having the burst time will be come at first. After that, other will be listed. Here the least burst time value of the particular process is process P4, that is 3. It is going to be come here. For the process P4, the burst time is started initially from 0 to 3. After the least value is 6, that is for the process P1, that is going to become here. 6 plus 3, we get 9. After that, the process P3 is going to become here. Here the value is 7. Adding the value 7 to the particular value, we get 9 plus 7, the value is 16. Next, for the process P2, we are having 8. 16 plus 8, the value is 24. The waiting time of a particular process P1 is 3, P2 is 16, P3 is 9, and P4 is 0. We have to forward the value which is presented here. We should represent here. After that, we have to calculate the average waiting time of the particular process by adding this 4 value divided by 4. We get 7 millisecond. Comparatively, the shortest job first scheduling algorithm can be solved by using another approach that is called both the arrival time and the burst time has been listed here. Here, the different types of process has been given and the arrival time has also been given. Here, we can have to take the particular process based on the burst time. For example, the process P1 is having a very long burst time, hence it is split into two sequences. One is here for the process P1, only 2 of the values has been taken. Rest of the values had been added here. Like this, we have taken for the process P1. First, we have listed the value from 0 to 2 arrival time. Next, for the process P2, we are having a value of burst time is 4. Hence, 4 plus 2, the value is 6. After that, the process P3 is having a burst time of 6. Adding 6 to 6, we get the value of 12. After that, the process P4 is having the burst time of 5. 12 plus 5, we are having a value of 17. Here, already we have put the value of 2 here. So 12 minus 2, the remaining value is 10 here. After that, again the cycle of P1 has been came here. That is 17 plus 10, the value is 27 here. For this, we can represent it in a Gantt chart. We have taken this Gantt chart and it has been represented with based on this particular arrival time and burst time. So for the waiting time, the formula for calculating the waiting time is total waiting time minus number of millisecond that is executed by the particular process and the arrival time. Okay. Arrival time is given in the problem and the waiting time which we have calculated based upon this Gantt chart has to be entered. For the process P1, we get 17 and the number of millisecond the process is executed. P1 has executed in 2 times. Hence, it is deputed as 2 here. After that, the arrival time of a particular value is 0. Hence, the waiting time period of P1 is 15 millisecond. Waiting time period of P2 is 0 and P3 is 3 and P4 is 4. Like this, another example has also been given for you. Here, the arrival time and the burst time is given. So this also be done under this same condition. Here, the arrival time, here the burst time of the particular value of a process P1 is very large. Hence, Again, the P1 is going to be repeated at the 2 different time. First, the value of slot will be taken as 3. After that, the 7 value has been separated in the next sequence. Like this, we have to calculate the shortest job first scheduling algorithm. So next scheduling algorithm is a priority scheduling. A priority is associated with each process and the CPU is allotted to do the process which having a highest priority. A preemptive priority scheduling algorithm is considered with an example. Here, the process ID, burst time, and the priority of a particular process has been given. For example, we can take the process which is having the least priority order. For example, for the process P2 is having the least priority order, which is given here. For the process P2, the burst time is 1 and the priority time is 1. So we have listed here. After the 1, the least value of the priority is having is process P5, that is having 2 here, and the burst time is 5 here. So we are adding the process P5 here. 5 plus 1, the value is 6 here. After the 2, the highest priority is 3, that is for the process P1. Here, the value is 10. So 10 plus 6, the value is 16 here. After that, 4 is the priority value. 4, which belongs to the burst time. 2, so 16 plus 2, the value is 18 here. After that, P4 having the 5 priority, that is having the burst time of 1. 18 plus 1, the value is 19 here. Hence, the waiting period of P1 is 6 and P2 is 0. P3 is 16, P4 is 18 and P5 is 1. Average waiting time is calculated and adding all these values and divided by the number of process, that is 5, we get 8.2 millisecond. This priority scheduling has a indefinite blocking. It having a lowest priority process to the highest priority process, and it can be represented with the help of a Gantt chart here. Next, we are having another example of a priority scheduling. A process ID has been given, arrival time, burst time, and the priority has been given. If it is given by this way, we are going to again consider the value based on the particular burst time. That is, 1 is the minimum number of burst time that is represented for the value P3. Again, we have to represent this value in this condition. For example, we can take the first process, that is P1 has come with the priority of 2. This is the least priority among all the process. So we have to take the process P1 is having the burst time of 4. It is represented here. Next, the process is having the same priority should be taken. So next, the process is having the priority that is called as P5. P4 is taken, having the same priority value. Hence, we are adding the 5 value to 4, we get 9. After that, P5 is also taken because both the values are same. 9 plus 5, 2, the value is 11. After that, the process P3 has been taken. Here, the value is 1 for the burst time. 11 plus 1, the value is 12. After that, P2 has been taken based on the priority value. Here, 12 plus 3, the value is 15. Now we have to calculate the turnaround time and waiting time. For the turnaround time, the formula is completion time minus arrival time, and the waiting time period is calculated by using the turnaround time minus burst time. Okay, this is how the completion time is calculated, is based on the particular value. Completion time is nothing but which we have get this value from the process is called as a completion time. That is, P1 is having 0, P4 is having 4, P5 9, P3 is 11, P2 is 12. Like that, the completion value has been calculated. Average turnaround time is nothing but we are going to add all the turnaround time value, which is divided by the total number of process, and average waiting time is also calculated by adding all the average waiting time value with number of process. The next scheduling is the round robin scheduling algorithm. It is usually a time sharing approach. It is a best example for the preemption scheduling algorithm. It normally proceeded in a circular queue. In the round robin scheduling algorithm, the process is going to be taken with the quantum values which is given in the problem. For example, here the arrival time is 0 and the time quantum value which is assigned as 4 millisecond for each round robin scheduling. Here the 3 process has been given, that is P1, P2 and P3. P1 is having the value of 24, P2 is having 3, and P3 is having the value of 3. P1, the highest value is there, which is going to be divided by 4. We get the value of 6. Hence, P1 is listed here for 6 number of times. Here 1, after that 2, 3, 4, 5, and 6 number of P1s are there. Starting with the P1 value, that is 0, it is divided into 6 quantum of time, which is equally divided by 4 number of times. Hence, 4 is listed here. After that, P2 is having 3, that is 4 plus 3, the value is 7. After that, P3 is having 3, 7 plus 3, the value is 10. After that, each quantum will have value will be having the 4 millisecond. Again, the P1 is having 10 plus 4, 14, 14 plus 4, 18, 18 plus 4, 22, 24 plus 22 plus 4 is 26, 26 plus 4 is 30. Hence, this value has been arrived. Now we are going to calculate the turnaround time. For the process P1, here we should take the highest value for the process P1. Completion time minus arrival time. Next, waiting time is calculated by using the turnaround time minus burst time. So this is a problem explaining the completion time of P1 is 30. That is, we are taking the highest value. P2 is 7 and P3 is 10. Turnaround time is calculated. Now we are taking the average value of the particular turnaround time. We have to add all the values and divide it by the number of processes. Here we get 15.66 millisecond. After that, average waiting time is also calculated like this. We are adding all the average waiting time value 6 plus 4 plus 7, and it has been added and divided by 3. We get 5.66 millisecond.